You did it. You're root on the box. Domain admin, right? Wrong. You own one machine. One. And in a real network, that machine is surrounded by hundreds more, a whole domain, servers, and the crown jewel sitting right in the middle of it. Getting your first shell was the easy part. This is where the real attack begins. This is post-exploitation. Same rule as always, and it matters more here than anywhere. Everything in this episode happens inside your own lab, or on a network you have explicit written permission to test. What you're about to see is exactly how attackers take over an entire company from a single foothold. We learn it to defend it. Authorized targets only. Every single time. So you're on one machine. What now? Post-exploitation breaks into 3 moves. First, loot. You steal everything of value on this box, especially credentials. Second, persist. You plant a way back in, so if they reboot or catch you, you don't lose your access. And third, pivot. You use this machine as a stepping stone to reach the ones you couldn't touch from outside. But there's a bigger prize. In almost every company on Earth, all those Windows machines are joined together into one system called Active Directory. It's the network's phone book and its master key ring, run by a server called the domain controller. Own the domain controller, and you don't own one computer. You own every account, every machine, the entire organization. That's the target. Let's loot. On Windows, the legendary tool is Mimikatz. Windows keeps credentials in memory, inside a process called LSASS, so users don't retype their password all day. Mimikatz reaches into that memory and rips them out. Plaintext passwords, password hashes, and Kerberos tickets, all dumped straight from a machine you now control. Every credential you pull is a key to another door. Linux is quieter, but just as rich. You raid SSH private keys. You read config files stuffed with database passwords. You scroll the bash history for a password someone typed by accident. You grab the password hashes out of etc. shadow, and you hunt for saved cloud keys. The goal is simple. Walk off this box with credentials that work somewhere else. Now you keep your foothold. Networks reboot, defenders hunt, shells die. So you plant persistence, a reliable way back in. A scheduled task that quietly calls home. A malicious service that restarts with the machine. Your own SSH key dropped into a trusted account. Or a brand new user that looks like it belongs. Assume you'll be discovered, and always leave yourself a second door. Here's where it gets dangerous. The machine you own can see parts of the network that you never could from the outside. A hidden server. A database. The domain itself. That machine becomes your bridge. This is pivoting, and it is how an attacker in the parking lot ends up deep inside the data center, one hop at a time. The tools make it almost easy. With proxy chains and an SSH tunnel, you route your own attack tool straight through the compromised box, as if you were sitting on it. Metasploit can auto-route entire subnets through a single session. And modern gear like Chisel and Ligolo builds a full tunnel into the internal network in seconds. From one foothold, the whole hidden network opens up. Now we go after the domain. Active Directory is what ties a Windows network together. Users, computers, and groups, all managed from the domain controller. Every login is checked against it, using a ticket system called Kerberos. It is brilliantly designed. But it is complex, it is old, and complexity is exactly where attackers live. And the ultimate goal has a name. Domain admin. First, you map it. A tool called Bloodhound collects everything about the domain, every user, every group, every permission, and draws it as a graph. Then it finds the path. It literally shows you the shortest chain of hops from the nobody account you have right now, all the way to domain admin, attack paths a human would never spot by hand, Bloodhound hands you in a single click. One of the sharpest paths is kerberoasting. Certain service accounts in the domain will hand any logged-in user a ticket that's encrypted with that account's own password. So you request the ticket, take it offline, and crack it with hashcat at your leisure. Service accounts are famous for weak, forgotten passwords, and they are often powerful. Crack one, and you have climbed. Sometimes you don't even need the password. Windows will often accept the password hash all by itself, as proof of who you are. So when you loot a hash with Mimikatz, you don't have to crack it at all. You just replay it. This is past the hash, and it means one dumped hash, from one machine, can log you straight into another as that user. No cracking required. Now you move. With a stolen hash or ticket, you jump from machine to machine using tools like psexec, wmiexec, and evil-winrm, running commands on each new box as you go. This is lateral movement. You loot, you pivot, you repeat, climbing toward an account in the domain admins group. And when you land one, you perform a DC sync. You ask the domain controller to hand over every password hash in the company. Game over. You own the domain. This is not theory. It is the exact playbook behind nearly every major ransomware attack. A crew fishes one employee for a single foothold. They run Bloodhound, they kerberoast, they pass the hash from machine to machine. Within hours, sometimes minutes, they hit domain admin, push their malware to every computer at once from the domain controller, and detonate. One click, to the whole company, in an afternoon. So how do you stop this nightmare? Start with the credentials, because that is the fuel. Turn on Credential Guard, so Mimikatz can't read LSASS. Give every service account a long, random, machine-managed password, and kerberoasting simply dies. And kill past the hash by never letting a powerful admin log into a low-trust workstation, so their hash is never sitting there to be stolen. Then build walls. Use a tiered admin model so the account that fixes laptops can never touch the domain controller. Roll out laps so every machine has a different local password, and one stolen hash stops at one box. Segment the network to strangle pivoting. And watch for the tells. Bloodhound collection and DC sync are loud, if anyone is actually listening. Let's bring it home. Post-exploitation is everything that happens after the first shell. You loop credentials, you persist, and you pivot deeper. Then you turn on Active Directory. You map it with Bloodhound, Kerberoast weak service accounts, pass the hash across the network, and ride it all the way to domain admin and the domain controller. That climb, from one PC to an entire company, is the whole game. Your lab exercise. Build a small Active Directory lab, one domain controller and a couple of workstations. Run Bloodhound and find an attack path. Try a Kerberoast, then a pass the hash, and see how few hops it really takes. This is elite, professional work, and it is completely legal with written permission. Next episode is our finale. Wi-Fi hacking, blue team defense, and writing the pentest report that turns all of this into money. Subscribe, because you do not want to miss the capstone.